So arrays are a little bit interesting because they're a data type that's not a data type. What do I mean by that? Well, it's actually a collection of pieces of data. And the way it's done and the way it's designed is to be very fast and very efficient. The key idea is your array is going to be one contiguous piece of data. Now, that's actually pretty important because that's going to be what makes an array very fast and efficient for us to use in a programmatic way. So if I think about it, an array has a name. For example, my array. And my array points to an address in memory. And we've seen that when we've talked about how a variable is stored inside of memory. Well, in a language like C, that array points to the first element of our array. And then, since the array has to be all of the exact same data type, you can see how we'd have equally sized chunks of memory. And this makes for very easy math for the compiler to figure out where element am I talking about. So a lot of people ask, why does an array start at element 0? Well, what it does is it multiplies the size of the element. So, for example, an integer might be 4 bytes. And then it says, how many index elements do I need to get? So 0 times 4 is 0. So it looks at that very first memory location. If it needs to go to a second memory location, it's going to say, well, how many bytes am I? I'm 4 bytes times 1. So it takes that first memory location and adds 4 to it. If I need to move to the third or fourth one, it's going to say, okay, let's say I'm the third one. 3 times 4 is 12. Add 12 to my base element, and it knows how many to index in. Because most data types are a multiple of 2, this means that the compiler, when it's running your program, can do a bit shift. And bit shifting is even faster than multiplying. So this becomes a very fast and easy way to work with something. If I look at a language like C, and I have here an array of 8 elements, just like you saw the 8 elements on the screen before, you can see my array here. If I want to say my array 0 equals 1, that's very easy for me to do. And this is a very simple form of array. A lot of our early languages use this. The array had to be all the same data type, and they had to be just that information. It's not a class. Let's compare this to a different language. For example, in Java. Java, being a typed language, is going to make me have all of my elements be of the exact same type. In this case, I once again have all integers for my array. But Java is using an array as a class. And so when I create one, you notice I'm using a new operator, so I'm actually creating an object that I can use. So this is really helpful. If I want to print out, for example, how many elements are in my array, I can say myArray dot and then length. Likewise, if I need to duplicate my array and I want to create a second array, all I have to do is create that, and then I can say equals myArray, and I can clone it. And so I have a couple of really simple methods that I can use to make working with arrays a lot easier for me. Now, could I do these things in C++? Well, sometimes I can. I would have to use maybe a variable to specify how big my array is going to be, or I'd have to build my own clone function that I could then pass in a clone to and then get another array out of. But it would be potentially possible. It's all a matter of how do I want to use them. In Java, it makes it a lot easier because it's built into the language. And so we have seen in some newer languages, Java is just one of them, and it's been around for over 20 years at this point, but other languages as well, where we're starting to use an object to hold that. Now, how does it hold the elements? Well, we don't completely know. It's all done internally. And so since it's kind of a black box and it's hidden from us, all we know is we put our values in and we get values out. And if you think about a good class definition, when we create an object from it, we shouldn't have to know how it works. So this is a really good thing for us. Let's look at one other language. Here I have Python. In Python, they have a list. Now, is it a list an array? Basically. In fact, you access it with square brackets just like you would an array. So if I want to come down here and say print my array, and I want to print the item at index 2, I can do that. Behind the scenes, my array is once again an object that's been created. And so I have a lot of methods that I can use. I have some properties I can access. For example, I can do things like get the size, I can sort this, I can append it, and just do a variety of different things. Now, you might have seen something a little bit weird with that, and that is I can append something. So no longer does my list in this case have to be fixed. I can say append, and I can give it a different value. For example, Bob. Now, you might say Bob, but wait a second. That's not a number like my other elements, and you are absolutely correct. In Python, it does not matter what type of element you put into your list. So you might be thinking, well, wait a second. If I don't care what element gets put into it, how does that going to work for me? Well, once again, that winds up being a hidden component. How they deal with that, how they store that information is totally up to Python. How it dynamically sizes elements is, once again, up to Python. So we don't have to worry about that. All we have to do is know how to use it. Now, you might ask, are there disadvantages to having dynamically typed elements and using it as an object? And yes, speed is going to be something that you're going to lose. It's not going to be as fast or as efficient as something like C. However, your developer time is going to be much shorter. And so what you lose by just a couple minor percentage points maybe in dealing with it and when it runs versus how much faster it is for you to work with and develop tends to be a worthwhile trade-off. So there's always that kind of justification you have to make with yourself. Is it better to do it and be a little bit harder for the developer, or are there enough computer resources to make it fast enough for me to use? Usually, if it's fast enough and we can make it faster and easier for the developer so that there's less likely to be mistakes, we're usually going to pick that route. And that's what you're seeing in some of these languages like C#, Java, and Python.